Hey, in this tutorial we're going to be looking at log graphs. Okay, so we're starting with the function log to the base a of x, where x is greater than 1. So these functions, our domain is 0 to infinity, okay, unless we have a horizontal translation. The range is r, the graph is always increasing, which you can see here, our graph's always increasing. Our x-intercept is at 1, 0, and we have a vertical asymptote, okay, at x, that should be at x equals 0, okay, or our y-axis. So I actually have a vertical asymptote here. Okay, and as a increases, so our base number here, the graph becomes steeper, okay, in this section, the graph becomes steeper, okay, but then it becomes flatter in this section. Okay, and the graph also goes to the point A1. So we'll have a look at some of our transformations that we can do. So we'll start off with dilations. So saying we've got the graph of y equals n log to the base a of x. Okay, so this dilates in the y direction or parallel to the y-axis or from the x-axis. Okay, they're the different ways of saying the same thing. Okay, so it stretches it this way, stretches it vertically. Okay, so our x-intercept, 1, 0, doesn't get changed at all. However, our point A1, okay, will become AN. Okay, and that's showing that vertical stretching. Okay, whenever we're doing a graph, if we've only ever got one intercept but we have a dilation, we need to put in another point so that you're showing that dilation. So it could be this point here. Okay. Similarly though, you can put in any value you want for x and yeah, you'll be fine. Okay, the graph of y equals log to the base a of mx. Okay, well this dilates by a factor of 1 on m, where in this one we're dilating by a factor of n. This time it's got to be a factor of 1 on m. Okay, in the x direction, parallel to the x-axis or from the y-axis. So it's stretching it this way. So, and our point 1, 0, okay, becomes 1 on m0, and a1 becomes a on m1. Okay, and I may not have sketched this graph that well. Okay, you're probably supposed to come back in here a bit more as well. Sorry about that. Okay, at this point here will be our 1 on m. Okay, our x-axis intercept. Okay, so we'll keep moving on. Okay, our reflections. Okay, just like our other types of functions, if our negative is outside our brackets or away from our x, that's our reflection in the x-axis. So because we've got y equals negative log to the base a of x, okay, that's our reflection in the x-axis. Okay, so our point 1, 0, our x-intercept doesn't change. Okay, and our point A1 becomes a negative 1. And it would look something like that. Okay, if we have y equals log to the base a of negative x, okay, because it's inside our brackets, okay, that's our reflection in the y-axis. Okay, so our x-intercept goes from being 1, 0 to negative 1, 0, and a1 becomes negative a1. Okay, and that's a little sketch of what it looked like. And finally, we've got our translations. Okay, so if we have y equals log to the base a of x take k, this is our vertical translation. This is moving it up or down. Okay, so our point 1, 0 becomes 1 minus k, okay, and a1 becomes a1 minus k. And because we've moved it vertically, we need to calculate the x-intercept. Okay, and you do that by letting y equal 0. And when you do that, we do our looping method and get to a to the power of k is what our x would equal. Okay, so we do that just quickly over the side here. So we can say, well, 0 equals log to the base a of x take k. Well, we'd add our k on and say we've got k log to the base a of x. Okay, we do our looping method around a to the power of k equals x. So we get a to the power of k equals x. Okay, and hence we get our x-intercept. Also, we can do horizontal translation, where we've got log to the base a of x minus h. Okay, this is our horizontal translation. Okay, so if in here this is positive, okay, then we move to the left. Okay, if this is negative, we move to the right, same as all our other types of graphs. So our point 1, 0 becomes 1 plus h0, and a1 becomes a plus h1. So we know our x-intercept still with these ones. Okay, but we also need to calculate the y-intercept, but only if we've moved it to the left. Okay, if we move to the right, like I've done here, we've got to move our asymptote. Our vertical asymptote is found at x equals h. So you can see here, because this is obviously a negative, okay, we move to the right. If we moved it to the left, we'd have a graph that crosses here, okay, and we'd have a y-intercept, and so we need to actually find that. Okay, and again, that's just by letting x equals 0, okay, so you end up with just the log of some number, okay, will be your y-intercept. So got just a couple of worked examples to have a look at. So we've got sketch y equals log to the base e of x minus 2. Okay, so x minus 2, okay, is the only transformation that we have here. Okay, and so it's negative, so we're going to move it to the right. So we can basically get going for the word go here. Okay, so we would usually go through 1, moved it to the right by 2. So we're going to go through the point 3. Okay, and we're going to have a vertical asymptote then also at x equals 2, because we've moved it across. Okay, and we'd also have the point, which would be somewhere up here, which would be e plus 2, and that's going to go through 1. Okay, so we're also going to go through this point here. Okay, so if we were to sketch that, it looks something like that. Okay, if we're going to sketch this next one, we have y equals negative log to the base e of x plus 1 plus 2. So we've got a reflection as well as our translations. So because we're at the front, we're a reflection in the x-axis. Okay, it's outside our bracket, so that's a reflection in the x-axis. We're also going to move it to the left by 1, because we're positive, and up by 1. Okay, so if we draw some axes, okay, we're going to move it this way by 1. Okay, so we've got x equals negative 1, okay, for our vertical asymptote. Okay, also our x-intercept is usually at 1, 0, but we moved it this way, so it's actually going to go, it would go through here, but then we've got to move up by 2. So that point is now going to come up to 2. So we originally started here at 1, we'll come here, and then we're going up 2. Okay. We'd also need to find our x-intercept, okay, where we let y equal 0. Okay, so we go 0 equals negative log to the base e of x plus 1 plus 2. Take our 2 away, negative 2 equals negative log to the base e of x plus 1. Okay, divide by our negative, we get 2 equals log to the base e of x plus 1. So then we go our looping method, e to the power 2 equals x plus 1. Take our 1 away, x equals e to the power 2, take 1. Okay, so now we've got everything we need to sketch it now. Okay, at that point, you put in your calculator to work out what it actually is if you need to give yourself a better idea where it's going to go. Okay, but we're going to say it does something like this. Okay, and this point here would be our e to the power 2, take 1. Okay, so there's 2 other worked examples that are just sketching ones as well that you can have a look at. Otherwise, hopefully you can get through the questions.